Okay, good evening, my esteemed viewers out there. It's your favorite tutor, the formula. So, in this evening class, we are going to be looking at some mathematical and statistical signs and symbols. We are going to look at some signs and symbols in mathematics and statistics and what they stand for. Now, we are going to take the first one. If you see a sign like this sign simply means greater than. This means greater than. Greater than. So then, when I write the sign like this and I cross it, it means not greater than. This is not greater than. Now, if I bring the sign like this, it means less than. Now, if I write it like this and I cross it, it means not less than. This is not less than, not less than. Now, when I have a sign like this, okay, let us continue like this. If I write like this, you see something like this. This guy means not less than or equal to, not less than or equal to. Why? If you see like this guy means not greater than, not greater than, not greater than or equal to. Then, if you are moving in mathematics again and you see something like this equal to, this equal to. Then, if I write this and I cross it, as you can see on my board, this is not equal to, not equal to. Because these things, they are very, very important. A prospective or a potential mathematician, somebody who wants to be very vast in mathematics, is duty bound to understand all these things. These are the basic building blocks of mathematics. These are the bedrock of mathematics. So there are things you need to internalize in your photographic memory. Just have them at the back of your mind and never to forget them. Now, if we see something like this means it's a subset of. And what is a subset? A subset is a set that can be taken from another set. So any set that is obtained from another set is a subset. Why? If I turn it like this is a superset. Now, a superset is a set that contains another set. So any set from which other set can be taken is called a superset. The superset of all supersets is what? Is known as what? A universal set. So a universal set is a set that contains all elements that can be used to solve a given set problem. Please take note. Now, if we have something like this, this is interset. If we have something like this, interset. Now note, if I have something like this is not a subset of, not a subset of. If I have something like this, not a superset of. This guy means not a superset of. Now, if I have something like this guy means union. Union is a union of sets. Union of sets. What is a union of sets? Union of sets is a combination of two or more sets without repeating any common elements. Interset of any set is element that is common to what? To two or more sets. So any element that is common to two or more sets is an interset to those sets. Now, if I have something like this guy simply means is a disjoint set. Disjoint set. Disjoint set is a set that has no common element. So When the intersection of two sets is 0, then those two sets, we say they are what? Disjoint sets. So two sets are disjoint when they have no common what? Elements. Now, if I have something like this guy means is an empty set. Empty set. Somebody may say, what is an empty set? An empty set is a set that has no elements. So when a given set has no element, we categorically say that the set is what? An empty set. Now, if I have something like this guy simply means is an element. Is an element of. Now, an element is an item or an object that can be found inside a given set. Now, if I have something like this, if I cross it, it's not an element of. Is not an element of. Please take note, it's not an element of. Now, if we have something like this in mathematics, you see three dots. You see three dots like this. What does this guy mean? This guy simply means therefore. We introduce these three dots whenever we are trying to present our answer. So once we are done with our solving process, or once we are done with the solution to the problem, for we to present our final answer, we just write this three dots. Now, if you see something like IFF, in mathematics, IFF is a conditional statement. It simply means if and only if. This guy means if and only if. So if and only if is used to introduce a given condition. That is what this guy means. Now, if you see something like this in mathematics, this man you are seeing, we call it expectation. We call it expectation. Expectation is used in statistics to find the average of a set of numbers. So the expected value of a random variable is the mean of the variable. So this is how we write mean as far as statistics is concerned. Now, if we see something like this guy means sigma, which means summation. Sigma is summation. Summation. This guy is sigma and it is summation for discrete data. We use this guy in statistics whenever I want to get the sum of a given number of observations or a given number of data. Now, if you see something like this guy is called sigma again. Sigma. And this guy is used in mathematics when we are trying to get the sum of a continuous function. So this is sigma or elongated s. So this elongated s is used to find the sum of an infinitesimal group of functions. So those of us that are very vast in mathematics know that this is what we call the integral sign. So the integral is a sigma sign, and this sigma is just like this counterpart in what? In discrete data. So this is sigma for discrete data. This is sigma for continuous data. Sigma, which is summation. Summation. Okay. My esteemed viewers out there, I think this is the much I can take in today's episode. So in our next class, we are going to continue exactly from where I'm going to terminate now. And we are going to look at other mathematical and statistical signs and symbols and their implications. Have a nice day.